Okay, in this video we're going to look at semiconductors, but first of all, this part of the video we'll look at diodes. Not very much talking, just revise you of the basic elements for each of the types of diodes: silicon diodes, Zener diodes, and LED. So let's just talk about our silicon diode. So current only flows in one direction, flows in the direction of the arrow that's on the actual diode symbol, anode to cathode, so greater potential to less potential. And if we look at a transfer characteristic graph, as soon as we get to forward bias, which is approximately 0.7 of a volt with silicon diode, then it starts to conduct, and it conducts really rapidly. So current flows really quickly. So with all diode type components, we use a safety resistor. So if we look at it on this circuit here, if 0.7 of a volt to conduct, there'll be 0.7 of a volt across here, which means then there'll be 8.3 volts across then our resistor. Okay, quite useful for, well, I'll leave you to work that out. It's only a short video. So our LED, same idea, forward bias. When it's in forward bias, it illuminates. Looking at the graph, that bias voltage for forward bias will depend on the color, so we need to look at on a manufacturer's data sheet, or be told, or something like that. So for a red LED, it's approximately 1.8 volts. For it to illuminate, though, we need sufficient current to be flowing through it, so we also look on the data sheet. So typically around 10 milliamps should be enough to make an LED illuminate. So if we look at the same idea as we did just before on our silicon diode, with 1.8 volts across there, which means there's 7.2 volts across our resistor. If there's 10 milliamps flowing through the LED, there's also 10 milliamps flowing through there. So that's, remember, how we calculate the safety resistor value. Okay, you need to look at the voltage across a particular component. Right, moving on, our Zener diode, we always use it in reverse bias, but that's what it looks like, because in forward bias it behaves a bit like a normal diode. Okay, but its magic properties come in reverse bias. They're precision devices. They're manufactured to different voltages. So this one that I'm using would be a 5.5 volt Zener diode. You could get, there's lots of them follow the E24 series. So they are precision device. So we buy it according to which breakdown voltage, reverse breakdown voltage we want. So that's our reverse breakdown voltage. So look at it in the circuit here. Then it's in reverse bias. So I've switched it round. So there's 5.5 volts across there, which means then long, isn't it? Can't add up. There we go. And then, so there's 3.5 volts across our resistor. Okay, for it to conduct, there must be a holding current. There must be sufficient current going through it. We'll look at the holding current when we look at using Zener diodes in our power supplies to create a voltage regulator. But sufficient to say at the moment, if we tap off a voltage here in the middle of effectively at the potential divider, we'll get a rock steady 5.5 volts. So they're very, very good at providing reference voltages according to what Zener diode we choose.